Alright, so in this video what we're going to do is make our FOF. We're going to make this deep complex FOF system, right? And I want you to pay attention to everything we're doing because we're going to go fast paced, and I hope you watched the last video because again, this is going to build off of that. The UDTs that we made is going to be built upon that. So we're going to go ahead and get straight to this, right? So I'm going to go kind of fast and we're just going to get straight to it. So we're going to add a couple rungs here. Now what I'm going to do is I'm going to come in here and I'm going to use a certain instruction, right? It's going to be a FBC, right? And this is going to be basically a file bit comparison, okay? So first off, I'm going to make the source file that I'm going to be using, right? Now I'm going to call this is going to be called system. We'll just call this system faults or system, and then we'll do underscore faults so you guys can understand. That way you guys can keep up with what we're doing. So and then we're going to use our UDT, right? So we're going to call it UDT, and this is going to be the FOF UDT. Okay, so why am I doing that? Okay, and I'll show you because I'm going to use a certain part of this UDT. Okay, I'm going to use at this point I'm going to use the filtered part. Okay, so when it comes down to it, I'm going to use the filtered part of this, and I'm going to use this as using this this file bit comparison. Basically what we're going to do is we have to start out with the 0. Now in the reference section we're going to create an actual section where we're going to create the same dimension of what we did in the last video. Again, we did 15 dents, with 15 dents is the equivalent to 480 positions, 480 of the array, right? So again, we're going to do that. So I hope you watched the last video. Again, so this is going to be called all zeros. Okay, and this is just basically going to be doing that. Now we're going to do this the same dimensions. We could have added this into our actual. We could have added that into the actual, the UDT that we did, but we want to keep it separate because again, it's all zeros. We're going to make sure that this stays all zeros. Okay, so we're not going to add anything to it. It will be, if you look in the data table, it will be, the data table will be all zeros. We want to keep it that. Okay, so that's really where that premise is. Okay. Now when you come down to it, you have another section, and in this section, this is going to be the result section, right? Which is something we could actually incorporate it into the UDT as well, but for the sake of what we do, we keep this separate, right? Because we generally, when we build this, we use these same features. Like this would be like section 1, section 2, section 3, so we would actually use this in different sections. So the reason we would keep it separate is because all zeros would format in anywhere, and the result would, obviously the results would formulate to here in this specific one. So we'll call this results for system faults. And then we're going to keep this the same dimension. Again, you have to keep the same dimensions of what you're doing so that we're keeping the same array and we're doing this the same way. Now, again, when it goes down to it, you're going to need to when you're doing this, you're going to need to start with the same thing, right? So starting with 0, and if you haven't used a file bit comparison before, that's exactly what it is. So now this next section is going to be basically your first control of this file bit comparison, which you're going to have two controls. You're going to have the compare control and you're going to have the result control. Okay, so this may get a little complex, but again, stay with me. We're going to actually explain this a little bit deeper. So we're going to call this FOF, and then we're going to call this compare control, right? So then we can actually abbreviate that a little bit better. Let's just abbreviate that a little bit better. So there's no dimensions here because again, it's just this one instance, and then we're going to do the same exact thing down here where this is going to be the result. Okay, so this is another control of the file bit comparison. Again, stay with me because again, when it comes down to it, this is something you guys requested. So I want to make sure that I follow through and give you guys exactly what you want. So this is the result from that, and then we're just going to call this control again, and then again that's going to be the actual result, right? So the length is going to be our dimension. Now the length of the dimension, right? So you see in this instance, right, we have the length of the dimension, right? We have the length of what we're doing is 15, right? So the result, or the length of what we're doing is 15, and that's going to be reading from here, right, which is 15. This is going to be all zeros is 15. The result is 15, right? So all zeros still needs, we actually still need to come in here and itemize that down a little bit down. I forgot I didn't do that. And then that would make sure that this is actually reading properly. Now, again, when it comes down to it, this is all zeros. That's exactly what that should be, right? This should actually, the next section should be the same thing, so that this is 15 dents. This is going to be 15 dents based upon the UDT that we made. This is going to be the zeros is 15 dents, so the array of data is 15 dents. The array of data, the result, right? The result is going to be 15 dents, right? And then it's going to compare that against the 480, okay? Now, when you come down to it, we'll actually see that. Now, what we'll do too, and what you don't want to do is you don't want to have your actual compare just running all the time. So what I like to do is I like to throw in a compare function, and I like to come in and throw the compare function in here and do what you actually do is pull out the compare position, right? So the control position, and you would, if it equals 0, so I'll show you. You would say if this position, right? So dot position equals 0, right? Then you would allow that. And then, but see, and then you still need to have the control done, right? So you still need to pay attention to the FOF control done bit. So you still need to have that same done bit in here, and you need to make sure that that is not done, right? So you still need to have this in here, and then pick the done bit as well. So this has a done bit as well. So you see that, and that is there. Now, just coming in and doing that, we can actually see that you know, this is going to actually watch. Well, we'll assemble that real quick, and there's an incorrect range of it because this is supposed to be 480, because that's the actual. So I did forget to put the actual length right here, and this is important too. So I want to break this down to you. So if you think about this, right? You think about your array, where your array of data in a dent is 15 dents, right? So you got 15 dents of data. So 15 of your double integers, right? Which equates to 400 and a length of 480, right? So if you did the math on it and you broke out a calculator, it would equate to 480. Down here, the length is looking for your actual array, right? So this is your complete array data. This is just looking at how deep your array is, how many dimensions it is, right? So how many dimensions your length is down here, and this is the actual data. Okay, so that's why that would actually do that. So then we come in and assemble that. So we have our first piece in there, right? That's in there first, right? Now, again, so we need to add some more logic in here, and we're going to do that now. Okay. Or come in and add a little bit more logic in here to show you how this stuff works. You see it's scanning right now. It's actually rolling through itself. Of course, we have no filtered data to actually go through, so I'm going to explain that, and I'm going to actually go through and add that now. So what we need to do is we need to add in our mass data, right? So if you've seen the last video, and I hope you did, if you didn't, I highly recommend it. You have to go back and see the last video to understand this. But we're going to add some mask moves in this video. Okay, so we're going to add the mask moves in here now, so we can have something to compare upon. All right, so as I said, you know, doing this mask move, I mean, you need to go ahead and add some data in here. So first, you can come in and get mask move, or you can merely just type in, you know, MVM. Okay. Now I want you to understand that. And so we're going to do a couple different layers here. And just to keep this simple for you, is we're going to basically Control C, Control V, just a couple different layers. Okay. Now I'm going to add is, you know, just enough to get in here and come in here and do this in each one of these. So I'm going to add these in here. Okay, so I'm going to add these in here. I'm going to show you exactly what I'm doing. Okay, so we named this system faults, right? So you can almost drag this up here. You can almost drag this up here and grab the right thing. Okay, so I want you to understand this. Grab the right thing. So we're in system faults, right? Now, in system faults, we need to add the first out fault. Okay, so we need to add this first one, and then we're going to go ahead and add the second one. This is going to be the filtered data that we're adding. Okay, so now you're going to start seeing a pattern here. Once you start like looking for a pattern, you see we're steady going down, and we're going to add this first layer of information in here so that we can actually copy, or we can actually understand how we're doing this. Not necessarily copy, but you know, you can understand the layers of the data that is being implied. Okay, now, and again, the reason for doing this, and you'll see this in just a second, is you have to filter the data. And why do you have to filter the data? Because you're comparing it against zeros. If you weren't comparing it against zeros, then you couldn't keep track of your information, for one, because obviously there's always going to be a zero. So let's figure that out. Let's make sure I got that right. Yeah, I did have for some. Okay, so yeah, let's get that 10 in there. Let's get that 10 in there, and let's get that 10 in there. All right, let's get. All right, that's a 11. We want to have that 11. Okay, so now we need to add some more in here. Okay, so let's add the 11 and down here, and you're going to start seeing a pattern here, and I promise you in just a second. We just got to get all the top layers in. Okay, so we're adding our the top layer of our UDT in, right? So we want to add this in here. So now we have all of them in there. Now we're going to use our mask data. Okay, then we're going to come down here and drop down here, and we're going to use our mask data. Okay, so coming up here. And then again, so this is using the mask data. Okay, this is going to be using the mask data. Now, we're going to come in here and add these in here. Now, what I want you to understand here is this mask data needs to be compared against a -1. And I'll explain this in a minute. But it needs to be compared against a -1. And I'll show you that exactly why in just a minute, so you understand the data. Because this, when you're talking about a system like this, right? You're talking about a system that handles large amounts of data. You need to understand data manipulation and how you do this. So you can go ahead and copy these over and make sure, as long as you keep track of where you're at, you know, you're on 5 here. You're on 5. We need to get a 5. See, it's just that simple, right? And then make sure you put that in there, -1. Because if you don't put the -1 in there, it's not going to actually transmit the data properly. Okay, and a lot of people are going to be like, well, the -1 should fault out the processor. No, it's not going to fault out the processor if it's in a data type. Okay, so think about that. Just think about that for just a second while we go through this and add the rest of these in here. If it's in like a timer, yeah, okay, but a -1 is not going to fault out any processor or do anything like that. I mean, this is live in a processor right now. If it was doing that, it would fault it out right now, right? Think about that. So I keep saying that for the simple fact of some people are going to get what I'm doing, and some people are going to ask many different questions. But as soon as if you follow through here and follow what I'm doing, I promise you, you will get this, even if you have to watch it twice. So, and it's just as simple. Keeping track of the data that you're passing through it. This is your data you're passing through this mask. What does a mask do? What does a mask move do? Right? It actually manipulates and it masks the data that's going through it, right? So we want to mask the data through a -1. And I'm going to show you this in just a second. Because what does -1 do? Right? And so let's see, pull this down here. And this next section is going to be the last section for that. And then we're going to add in the top. Okay, this is a 12, this is a 13. 13. See, even myself, you know, you got to keep track of this stuff, right? So talking in a YouTube video or talking in a video, in any kind of video, won't throw you off sometimes. So now we have our -1s. Now why did I do that? Okay, so -1 equates to what? What? It equates to 1. It equates to 1. That means every bit in that equates to 1. So that means I want to actually monitor every bit. I want to monitor every bit in this dent. Every bit in this dent right here, I want to monitor that bit. Now, in order for me to pass that bit through that, okay, in order for me to monitor every bit through there, I need to have every bit tracked. And how do I track every bit? I have to enable, and think of this, every one of these, every like 0, 1, 2, 3, all the way down to 32 or 31 is going to be, if it's a 1, it's enabling the pass through. It's enabling the ability to actually monitor that data in that mask. Does that make sense now? So now what we're going to do is we're going to call this the filtered data. Okay, so we're going to drag this down and we're going to go to our filtered data. So now you see why we kind of built our FOF like we did, right? Our UDT like we did. So let's go ahead and add this last section in here, okay, just of this filtered data, right? We're adding this in here. So now you're starting to see the pattern here. You're starting to see how it works. You're starting to get fluent with it, right? So hopefully that made sense of tracking this, going through, and this is a 4, right? So let's track this and make sure that we get everything right. But as we're doing this, right, so make sure if something goes through here, it's got to be enabled here. If something goes through here, it's got to be enabled here to get to here, right? Or if it's not a 1 here, if all the bits aren't a 1 here, it's not going to monitor that the bits in this tab to get to here. So that's all we're doing, is we're enabling that section, okay? That's really all we're doing. So I'm going to come in here, label these. This is a 6, this is a 6, this is a 7, pick the 7. So you see how important that UDT was. Let's actually not do that. Let's come over here, let's pick 8, and then 8 we'll drag down here, we'll drag 8 over here, we'll drag it again, and we'll come in and do that. Now again, so you start, hopefully you're grasping what we're doing here, because you're going to see in a minute as I pass data through here, you're going to see that it does. Let me make sure I get this right. You're going to see this data pass through here, and you're going to see if I turn one off, it's not going to care, right? If I turn one of those off, if I turn one of those to 0, it's not going to care. And I can manipulate that data. If I want to filter the data a different way, I can just change that from a -1 to whatever I want to filter it on, right? So all this is actually good now. Okay, so all this is good now. So here's the instance. Okay, so now if I find a fault, okay, if I find a fault, then it's monitoring it here. So if I put in a fault here, it's going to check it right here, and it's going to find it. See, the position was found right here. Position was found. It's no longer scanning. It found a position. Now, this isn't all the data that we're just putting in the data right now. And again, we're only 19 minutes into this. So what we're going to do is add another rung in to clear this data, and then we're going to start adding in more functions as well. So with any data system, right, we need to add in some kind of reset. So I'm going to add these top rungs as a reset. Now, this is going to be pretty simple, right? This is going to be like a natural system reset or something. Say, for instance, this could be system reset. Like, say there was a global reset or something like that. Or let's just call it that. Let's call it global, so that you can understand exactly what that is, right? And this is going to be, say, for instance, this would be the FOF, or first out fault. Let's call it first out fault. I keep spelling fault wrong. Fault reset. So that way you understand exactly what it is. Okay, and then for this, what we're going to do is we're going to come in here and add this in here. We're going to drag this bit down here. Now this bit is going to be used on our HMI, so don't worry, we'll use that. Now I'm going to do a couple things here. I'm going to grab a fill, which I'm going to do here. I'm going to grab a couple different branches, and for this I'm going to actually manipulate the data. Okay, so what I'm going to do is I'm going to fill this stuff and then I'm going to move it. So I'm going to do one as a fill down here. I'm going to add this in here, down here, another one, let's add another one. These two can be moves, right? So actually, let's just transition that. For right now, we'll add this one in here. So what we'll do is we'll do a move, move. I think it's right here. Yeah. Sorry about that. And what we want to do is we want to actually throw zeros in here. So this would be 0, 0, 0, and this is going to be actual length of 15 because that's our dent length. That's our dimensions. That's our array length is 15, right? There's a 480. We're going to add the data right here, right? So we're going to actually pull this in here. We're going to pull this in here, right? So we're going to clear that data. We want to clear that. And then we want to clear the results, right? So what do we call the results? Call them results right here. We want to clear the results down here. So we want to grab that, so that's our system. So we'll call that r.sys faults. Okay, so we actually want to clear that. Come down here, clear that. And then you want to clear the actual position of the actual control. So you can grab that here if you want to. You can actually come in here and grab that here to make it easier for you. But you want to clear this. And all we're doing is clearing the control here. Okay, we're clearing the position. And I'll show you this. Okay, so now this gives an actual reset ability, right? So we've actually come in here and scrolling, right? Now, as it's doing that, so as the position is there, right? So as we come in here, we want to clear this data. So right now, it's found, right? So actually, it's not found because we have our data up here. So let's clear this real quick. Clear, and we still haven't put all of our information in here. So if we come in here now and we put in like 15. Okay, so then that pulls in a 15. And that says it's found in at position 4. So that gives us a fault, right? So it's no longer going to find anything. It's no longer going to do anything. And again, if we want to, we can clear that data. We're clearing the data. So now we have a system that we can populate data off of, right? We can populate data off of this system, but we still have to add faults into this. We haven't added any faults into this yet. So this is where all this is going to get tied into, and I'm going to show you that right now. But before we actually get into the faults, let's actually add one more rung here. And this rung, you know, is actually something that you can use to understand where you're at. right? So we want to actually add a not equal to. We're going to add 2 of these. And then in the not equal to, we're going to say this is going to be a bit at the very back side and of these 2. And this is going to be actually fault found. So we'll say fault active. Right? And that's going to be just a standard bool, right? It's just going to be a standard bool that we'll use throughout the system. And what we want to do is monitor this again, so we can easily drag this from here, go up here, and then pick the position. That's just picking the position again. And what we're going to do is say position is 0, and this is 480. So that's going to pass through that, right? So it's not equal, right? And then we'll come in here, equal that. So this is not going to be there. But now let's come in here and let's show you that. Let's do a different one, being that we've already did one before. Let's come in here and do, for instance, that one you can see. So this will be that, and that is found. Let's see, that's found one, and I'm not sure if let's see if make sure we're monitoring that data right. And I might have this in here actually a little bit different than what it should be. So this is not equal to. I think it should be both, right? Actually, I think I know what I'm missing out is I need to add this up here as far as this goes. I need to add this down here as far as what I remember. And I also need to branch this and circuit this. So all these can be on the outside. I want to grab that. I want to grab the whole instruction and then grab the whole instruction again. And now what I want to do is add in the FOF control down here, which is going to be, again, so this will be basically sealing in like a latching in this. This would be the control right here. We'll latch in the in. And latch in the in bit. Okay, so now if a fault's found, it's going to actually latch that in. And that will cause that. That's what I was doing wrong. And so now this is where that clear bit comes in place. So that comes in place. You toggle that, it clears it. Everything comes in here. And we still got to have a scenario down here. So again, so you see all this is working. All this is working. And the in is what you need to do to actually control it, to allow it to actually fully function. So let's actually come in here and do that again. Let's put in let's do another one for that example. Okay, so fault active. Good. So even if now I can clear that, right? It's not going to do anything because it still found that one fault. It's not going to change it. If that fault goes away, it's not going to change it. You see that. This is the beauty of how to do a proper data structure, a proper data system, because it maintains that fault status. This maintains that fault status. It finds it exactly where it is. Watch this. If I put in a 2 here, okay, so it finds that fault status. See that fault status? Now, if this fault goes away and it knows it's at position 386, if that fault goes away, say that fault goes away, it still maintains that fault position until it resets. Why? Because it's already found it, right? It's not going to keep cycling and cycling and cycling because, again, it's already found that position. Now, that's the cool thing about using this. That's the benefit about tying it all in the way we just did. Now that we have our skeleton in, now this is just the skeleton. We haven't added in our faults. We haven't added in our ALMDs, but we come in here and add our faults in down here, right? So in this fault routine, what we can do is add in all of our faults that we're going to be using inside of this actual program. And we have to find them and put them in. So as we're doing this, it's going to get kind of long and drawn out. But what I want to do is actually start and add a couple of them just to show you how they work, right? So as we're doing this, I'm going to kind of just throw a couple of them in here real quick, and then we'll come in the very next video, because this is getting kind of long. We'll come in the next video and show you, because I'm going to actually I'll run the system and show you an actual fault happening, and that way you can see the fault actually pop up. But I want to actually show you this, right, and show you how this works. So we do have an e-stop in here, right? So we do have an e-stop system in here, and let's look in our state machine. All right, so our state machine has an e-stop, right? So we have an e-stop situation, and we want to grab this bit. So we'll copy this bit, it's the e-stop relay, and we're going to paste this bit in here. If that bit is active, then we're going to use one of our bits. Now, in this instance, we're gonna do a latch, and we need to start out to, and I know this is going to sound a little bit strange, but we're going to unlatch the very first bit. Okay, so, and I'm going to show you this too so that you understand it. So this is going to be using, again, if you can imagine, the same tag as we used over here, system faults. Okay, so again, this is going to be called system faults, and this is going to be using the actual fault, right? So this is going to be using the first out fault, and this is going to be, so we don't want to actually ever indicate that one, because that would be obviously improperly used. So in that instance, what we're going to be doing is we're going to dig this down to the bit level. Okay, and this is going to be down to the bit level. This is where I'm talking about the bits, right? So the e-stop 1 would be that bit. Now, generally speaking, what we do, instead of having the bits like this, is what we do is we alias it. So let me show you this. So I'm going to add another one in here, and I'm going to alias, and I'm going to call this alarm. We'll call this alarm 01. Okay, and we're going to alias that section. We're going to call this the system faults, right? And then we're going to go down to that first out fault, and then we're going to get the very first bit that we used. Okay, so now we've aliased it. So this is the exact way you should do this, right? So, and again, the whole thing about here is I just wanted to show it to you, right? I wanted to show you this is the actual bit we're using, instead of getting all complex and doing, you know, actually going through and doing multiple layers of stuff like, you know, aliasing and doing other bits. Aliasing is just basically saying, okay, this tag references this tag, and that's how it is directly tied together, right? It's not like an indirect thing, it is directly tied to that. Right, so then we'll call this that, and then we'll come in and do system fault again. So the system faults again, and then we're going to grab that very first bit. Now we're going to do these, and you can imagine this can get pretty drawn out and daunting, because you're going to do these for every single fault you have in here. And for those faults you don't have in here, you're going to put them in anyway, and then you're just going to basically AFI them out, right? So you would have them for all 480 bits that you're doing, and then you would just AFI them out. Now for our instance, well, we don't really need that, right? So we do have a fault, and what I want to do is we have ALMDs that we could use, but let's go ahead and just show the fault working. What I'm going to do is spin up this client, and what we'll do, we'll just to keep this simple, because this could get drawn out like really this, and I'll come back in a later video and show you a full system that I've done this on. But this shows this is going to be like all 480 bits, right? So this could be as big as you want to, but again, if you think about it this way, you would have this just like this. You would have this. You would have this, you gotta have this. I'll just make, I'll go ahead and make a couple of these just so you can kind of see, right? And again, this is going to be kind of drawn out, but again, because I hate to make every single one of these bits as we're doing it. So this is 02, and then you're going to come in, alias it, system. You can almost, like, if you wanted to make it quicker, there's a way you can kind of come in here and do this a little bit quicker. But when it comes down to it, once you build one, you kind of, you don't have to build it anymore. You can just kind of like import, export. But so say we're not using this bit, you want to come in here and AFI it. You want to AFI, and then you can easily come in here and use it anytime you want to. And this is what I was getting. This is what I was talking about doing for all of the 480 bits that you want to use. And you could make this much bigger if you wanted to. So you're not limited to what you're doing here. You're not. I just wanted to show you a large scale system that we're talking about. Like, everybody's been talking about, how do you do, a SCADA system through different, like all going back to, data manipulation and data controls and actually doing proper fault handling and stuff like that. This is a deep fault system, okay? Deep fault system. So understand, you can see your bits you're using, and we're just going to make these last couple, and I'm going to spin up the client real quick so you can see the fault take place. And then we're going to add our ALMD in, and then we'll show you that ALMD will give that data the proper illustration of the fault we want to actually populate. Right? We'll come in and add the information that we want to populate in that. And that's really where all this gets really powerful, right? So you may think, well, this, there's a much easier way to do this. This is actually a very good way to do this, and it's a very foolproof way to do this, right? There's no holes in this, none. It catches exactly what happens perfectly. And the reason is you can come in here and change your filters from that filter data that we did before. You can change your filters all you want to. So just understand that, as you're going through and programming something like this, it's the comprehension of what you're doing that really makes, the depth of quality, right? And this is just the first section, right? We're already like almost 30 minutes or something into this video, so I want to make sure that I keep this as structured and as detailed as possible. So we'll copy this, because we're not actually done with the full system yet. We have to add in our ALMDs to fully communicate to our actual HMI system. But we do have a working system. So if I do a fault right now, it will come in and find it in my fault system. Okay? It will find it inside of my system. My system does not have an active fault right now. Okay? But if I spin up the client, so if I were to open up the Factory Talk client, and let's see, open up Factory Talk, Talk Studio, open up Factory Talk Studio, and I spin up the client, and I'm gonna just pick my application real quick and spin this client up, because I already have it made. It's not a big deal. It won't take but just a second. See the application. So the motion application. And what we're going to do is spin this client up. So we're starting up, and this is, it's in grace mode. Yeah, not a big deal. That's just a simple little thing we have on that I need to resolve on this VM right quick. But not a big deal. It's not going to hurt us on what we're doing. And we're going to actually spin this up, and I'll show you the actual system running, right? We'll show you the actual system running again, right? So just like we did in the last video, we'll show it running. Then I'm going to hit an E-stop, okay? So I'm going to actually hit an E-stop. I'm going to actually show you in the code that it will pull up an actual E-stop fault, okay? So, but again, that's going to be through the system that we just put in using the UDTs and using all the file bit comparison and everything like that. So it's finally loading. And sorry about having to wait. You know how factory talk can be sometimes. Okay, so we have our system, and we're going to run our client. Now, I had the client file on the desktop. I should have actually opened it up. Sorry about that as far as the timing of that. So I do apologize for that. I could have just went up on the desktop and pulled it up. So I'm going to run my client, and this is the client, I believe, right here. So let's run this client and actually populate that. And this is logging in, and the client should actually be pulling up now. Is populating, pull up, is finally getting to the point where we're here, and this is going to start up. It's access control is what we're doing. Again, you've seen this. If you've seen my last couple videos, you've seen this, right? Now we have this in here. Now what I'm going to do is actually start the system, right? I'm going to actually come in here. We'll start the system. Okay, it's starting, and you actually see the system is actually running right now. Okay, so it is actually running, the servo is running, and what I can do is I can e-stop the system. So I can do an e-stop test. Okay, so as I do an e-stop test, I need to, it looks like I don't have the controls to stop the actual servo. So I need to verify that I didn't break my e-stop circuit. But this is an e-stop test. It's emergency stop state. So let's see. Let's go inside of our code and let's see if we have a fault. Our fault did detect, right? So we do have a problem with our e-stop, where we didn't, for some reason we didn't stop our actual, oh, I know why. I know why we didn't stop our e-stop. So in the controls down here, in the servo controls, I didn't add the e-stop control here. So this would never have stopped the this would never have stopped that. But when it comes down to it, because it only stops during that. So I need to add the e-stop in here, and that's perfectly understandable. So let's do that. Let's add the e-stop. I believe it was in this last one, and I know we were talking about, we were doing this completely different. We were talking about FOFs and stuff like that, but I want to fix this while we're here, because this is something that I did not add into the system. And it's not that the state machine knows it's e-stopped, but it also thinks it's still ready. So that's fine too. So we'll say the system is running, and the only reason the system is running is because it's still in the virtual jog. So what we'll do is bring this back to the state. The e-stop state should be, if that is in, if that state is in, we're gonna do some state machine troubleshooting real quick. So the e-stop state is made. If the e-stop state is made, if not, then here, and we are currently in the state of running. Actually, we're in the state of 0. State machine is in a state of 0. So the state machine did what it was supposed to do. Okay, so that makes sense. So that's good. The output of the state machine is not being monitored, which is something that I did not put in. So that's good to know. It's good to know. So the what we can do is just like what we did here. Okay, so in the controls, you see this is the output state right here. What we can do is add another bit that says right here, this would be the output state, and this would be the stop, right? So this would be the control. So this would be state machine. Oh, I spell it right this time. This would be e-stop. So then we'll alias that, Again, so we're making all these bits live, right? Because we can. So, I mean, it's like, this is really, really powerful stuff. And this needs to be our SSS out. Okay, so this was our 0, and we didn't use our 0 before. But, which is weird because we just didn't use it. And so now we're going to come in here, put that in there. And our 0 state is not populated, but we're showing a 0 state populated in here. So state machine is in 0. Oh, we need to go back to our driver. It's in a state of 2. Okay, so the state of 2, state machine, state number 0. Okay, so the state machine is in a state of 2 because we're not monitoring the e-stop. So we're saying if this comes in, we're not monitoring this. We don't really care. We need to have the e-stop in here. This is all being ignored. The e-stop is good. Okay, so this is here. It's showing that. This is coming back a state number of 2, which is coming from, that's coming from state machine is right here saying 0. So let's see exactly why this is being overwritten. I think it's just as simple as me adding the e-stop. The e-stop in this right here. I think it's just as simple as that, but we'll see. And it did not change it. Let's come in here, do some more troubleshooting. I think it's because we didn't add our e-stops in here. And let's paste that in there. System is running, still in a state of 2. And this is actually getting the state number from which the actual state number is 0. So the SSL state number, that's going to state number, and that's given the state number. So I wonder why this is not updating. Because this is going to here, which is here, which is 0 is 2. Oh, I'm using the wrong bit. Exactly. That's right. That's why. Okay. So, in essence, I did the wrong bit down here. So this should be 2. Okay, so let's remake that bit. This bit should be, because I actually called for a different bit. When I built this system a few years back, I used a different bit level. And this is to be state machine, and then we'll call this e-stop, because we already have another one, and unless we take it offline, we can't actually name it the same. So we'll call this machine, and then we'll look for machine stop, and we're looking for SSL out. We're looking for state 2. It looks like I've already used it though, so I wonder why I haven't. That's 10. Wrong one. It's 10. This 10. This 10. So it's 2. And that's not active either though. So let's look at why. Let's look at what bits are active inside of that state. Let's go over here. Let's look for machine SSL out. We're gonna fix this. Don't worry about it. This does not. This still shows that the point was valid. Our stuff was working for our fault system. So this is the machine out is a 2, and oh, this is the bit we need to be using. So we'll cross-reference that. Cross-reference. See where we're using it. We have it right here. And that's why, because I built it, but I never used it. That is exactly why. Well, that is slightly embarrassing. But it is what it is. And that's part of troubleshooting, that's part of programming, that's part of building stuff live, so you get to see the whole process. So that gives us a stop, and we can take out this other stuff that we did, because honestly we don't need it. If you have proper state control, I mean, it's good to monitor it. If you have proper state control, it doesn't matter. So this is why the finite state machine is so brilliant, because it just works, right? And the same thing with here. Well, largely we're unlatching that bit, right? I want to come in here and paste that in here. So we'll do this, paste that in here, just like this, and do that. Okay, so I wasn't using that bit, that e-stop bit, the whole time, and that's probably why that issue happened, because when I redid if you watch the last video, the last hour video I did, where I redid everything, well, I did not, I added the servo, but I didn't add the controls to monitor the e-stop. So with that said, if I hit the reset now, the start button, it won't do anything. Now if I cut the e-stop off, and then I reset, then I hit start, the system will start. Okay, so now the system is back into a running state. Now if it goes into a stop, it's going to stop the actual servo. Now that's the proper implementation, that's the proper way to do things, right? This is the e-stop test anyway. So, but again, going back to what we did, going back to the whole process of what we did with the actual fault handling, then that comes back and actually shows this, right? It shows the 100% tried and true way to do this, right? So let's actually go back and actually, let's fault it out again. Let's come back in, and so you can see in our fault handling system that we put in, because that's what we were working on, our fault that we populated is this e-stop fault, which is bit number 1, where we populated bit number 1 right here, right? So if you look at it, we populated bit number 1, which gives us a value of 2, okay, and we passed it through. Remember, we passed it through all these bits that were enabled. So again, if you have 16 bits and you don't have a 1 in every single one of those bits, then it's going to ignore it. So say for instance, if I did this, if I came in here and I said, well, I want to ignore this bit. Well, I can ignore that bit. So that's a -3 now. Okay, so now I can actually reset my system. So now I'll ignore that fault, even though that fault's still present. Actually, let me see something. Am I ignoring that fault? Am I ignoring that fault? Let me see. See if I'm making sure I'm doing the right bit right here. And I'm ignoring. Actually, I need to change that to actually, because this is going to be, that's bit number 1. So it should ignore, essentially I think it was already caught, so it's not gonna affect it, but let's see. That's bit number 1. Could change that. So it should ignore pass through. And that's the reason why so it's catching a position of 2. Let's reset that again. And it may be because it already caught it. I think it already caught it. So let's reset that. Okay. Alright, so let's come back in here. It's already caught it. Yeah, because see, it retains where it was. Okay, so it retains where it was. We clear it. And it did not clear this data because, let's see, it did not clear the data because we don't have the clear data in here. So I don't know if we need that. Let's see. Yeah, we do. Okay, so it's not clearing the data that's in here. So I think we need to clear our data here as well. So let's do that. And let's do the fill again. And I kind of like to have my fill up here and all my fills right there. And let's clear this data state. So this is extremely powerful, and actually let's try to get up there where it was so you can see it. Extremely powerful tool. But you have to I'm just trying to come in here and give you an example of that working. Okay, so let's clear the data now. Okay, the data is cleared. Okay, so now we don't have a fault. If we hit our e-stop, come over here, we do not have a fault because we're ignoring this bit. See that? We're ignoring that bit. Now, here's the thing. This is nothing's forcing this off, right? But we're ignoring this bit. Okay? So we built this all in the same atmosphere of what you just saw, right? So if you watch the whole video, you get to watch everything we just did. But the reason it's not monitoring that bit right now is because we have disabled it in the actual mask. Now if I change it here, it will catch the actual fault. Okay, so now it's caught the fault. But see, this is how the power of this file bit comparison is the fact of if you even try to manipulate the data and there's already a fault, it's not going to allow you to do so because it already knows there's a fault there, right? So even if I do this, even if the fault's still there, I can clear the data, but the fault's going to come right back, right? Now, if I come in here and I turn that off, then the fault, and then I reset it, the fault will go away because the fault's not valid anymore, right? So you see, but even when I tried to manipulate data before, when I was trying to give you the example of the mask, the filter, then even when I tried to manipulate it before, it was not allowing that to happen because of how powerful this system is. It won't allow you to actually manipulate something because it is a true full spectrum fault system, and you can use this in different layers and use this as a very, very, very powerful tool. This file bit comparison used the way we're using it, masking your faults, running back, having your faults in here, and then we haven't even come in and put our ALMDs in here yet, but we will come in the very next video and add in our ALMDs so that you get a fault and indicate that fault inside of your HMI. And I'm going to show that as well, so don't worry about that, but I'm going to go ahead and we're going to conclude this video and then we'll pick up on the very next one. So we'll see you guys on the next one.